involves changing the natural contours of the land and the moving of earth. The unabated demand for more coal to satisfy the increasing needs of production has brought about the extensive use of earth-moving machinery, where open-cast mining is a practical answer to our needs. Below the surface of peaceful pastures and acres of wheat lie the rich seams of coal beds waiting to assist in the recovery drive of this country's economy. To appreciate fully this vast project, let us pause in the office of John Mickey, the contractor's agent at Carrington's Coppice. The site under his management contains more than 500,000 tons of coal that have been lying dormant for millions of years, in 4 beds running more or less parallel. John Mickey's wall charts are colored diagrams. Red, denoting earth to be removed, is to remove the layer of topsoil to a depth of 9 to 12 inches. This is done by scraper excavators, which remove the valuable earth lying over the coal seam. The power unit is generally a crawler tractor, and the operation is started by dropping the steel floor so that it cuts into the grass, simultaneously lowering the apron but leaving a gap for the topsoil to enter. Topsoil is removed evenly. It is gathered in the bowl, and when filled completely, the operator closes down the apron, and the collected topsoil is cleared from the working area. But as the topsoil is to be replaced one day, it is stored outside the operational area of the site. As soon as the coal has been removed, the topsoil will be restored to produce food for the nation once again. The stage after the excavation of the topsoil is the removal of the clay, shale and rock, technically termed the overburden. When the ground is very hard, a rooter is used. 3 steel prongs, technically called tines, and a moving belt under power of a separate engine conveys the overburden into the Euclid dump trucks, which travel alongside the loader, keeping pace with it. Completion of loading is signaled by a klaxon. The filled truck pulls away, and the operator pauses long enough for the waiting empty truck to move into position and receive the next load. As shown here in slow motion, the conveyor belt delivers the overburden into the waiting trucks at the rate of 1 ton of overburden every second. The operator of the tractor and the loader, from his driving seat, controls all loading and conveyor mechanisms. The loading of a truck takes about 30 seconds. And as soon as it is filled, the truck speeds off at top speed to the dumping ground, passing empty trucks returning to the loader. Meanwhile, in order to expose workable areas of the deeper coal seams, the overburden of the second seam is removed. The method employed here is by the use of the walking dragline excavator type W150. It's one of the larger machines used for heavy excavation on open-cast coal sites, and its long range makes it specially suitable for this type of work. The excavator rests and rotates on a circular base 24 feet in diameter, and when it becomes necessary to change the position of the giant machine, the platforms below the working mechanism and on each side of the cab bear down on the ground and slowly lifting the 165 tons, drop it gently forward as it descends with an eccentric movement. Whilst the W150 is getting into position to resume work, let us glance at another machine for removing overburden. The electric face shovel attacks the walls of rock, shale and clay from below. Digging and slowly biting into the wall face, each bucket load will gather and load 2.5 cubic yards of overburden into the waiting truck. Only 3 bucket loads are necessary to fill the truck, and this calls for expert timing of a chain of trucks to be in readiness for the next load to be collected. The filled truck now moves off to the dumping ground. As the driver reaches that section of the site where the coal has been removed, so he backs the truck and, setting a mechanism into motion, tips the overburden into the gap, which must be filled to restore the site to its former outline. With a clear view from his cabin, the operator is digging hundreds of tons of shale, rock and clay every hour, and casting this overburden from a jib 135 feet in length. The interior contains the power unit, and the operator controls the movement of machine, bucket and boom. Every time the 3 cubic yard bucket bites into the overburden, it lifts about 5 tons. Constantly the area changes in outline as new cuts are made and old cuts restored. Mountains of overburden disappear and new mounds rise again on other sections. Old roads vanish and bulldozers force new roads into the mass of overburden to provide fresh lines of communication. On every part of the area, men and machines are steadily engaged in some form or another extracting the coal from the earth. 16 months of production at this site has produced 350,828 tons of good quality coal, which is over 40,000 tons ahead of the target figure. This production chart gives an indication of the progress that is maintained. The thin red line represents schedule rate of production, and the wavy green line, the actual rate of coal extraction. 5 million cubic yards of excavation will eventually yield over 500,000 tons of coal. At the coalface, the greatest activity is maintained, and blasting operations are constantly in progress to loosen the coal so that the face shovels can work easily and without obstruction. The principal aim of this entire project is to supply the greatest quantity of coal in the shortest possible time. Since the rate of earth to be removed against coal to be extracted is approximately at the ratio of 10 to 1, it is understandable that the moving of earth by the most effective method is of paramount importance, so that the face shovel machines at the coalface can be constantly at work. Excavation is proceeding simultaneously on all 4 coal seams, mainly by the use of forward shovels. The capacity of the buckets is up to 1 3/4 cubic yards, which is roughly the equivalent of the coal ration for 1 household per year. The buckets dig into the coal face and load the lorries in one continuous action. As soon as the lorries are filled, they proceed to the entrance of the site and are checked out. Here the empty trucks return to be filled once again, and the constant stream of coal-laden lorries pass out on their way to the screening depot. At some of the company's other coal sites, the rock formation is so hard that extensive blasting operations must be carried out before the overburden can be removed. A vertical drill is employed so that the explosives can be thrust deep down into the rock. The charge is set off by remote control after the area has been completely cleared of workmen and machines. A push of the button and hundreds of tons of rock are dislodged and can now be loaded and removed to the dumping ground. The face shovel excavator used here is a limer machine, and the action and operation is on the same lines as the face shovel machine at Carrington's Coppice. Three bucket loads fill the dump truck, which then moves off to the tipping area. A machine which is virtually identical to the walking drag line at Carrington's Coppice is the limer drag line. The jib is 80 feet in length, and the arc of operation being much smaller, the limer drag line digs and dumps the bucket loads of overburden with comparative speed. The bucket drags up the overburden in the same way, and the casting is on the same pattern as that of the W150. Machinery undergoing such heavy work and punishment must receive a constant maintenance routine to avoid breakdowns and delays. The pulleys at the head of the 135-foot boom of the W150 must be greased every 24 hours. Those of the bucket receive the same attention. Face shovels are constantly inspected. The bulldozer must be serviced. Many feet of wire rope are required to bear the strain of constant digging, shoveling, and casting. The existence of 4 seams of coal at Carrington's Coppice site demanded the employment of a number of electrically operated earth-moving machines. This meant that a power supply of 3,300 volts had to be provided. The local electricity supply company agreed to the erection of a substation to reduce their supply of 33,000 volts down to the required voltage. A land line of electric cable was taken to the edge of the workings. Couplings and junction boxes, spaced at suitable distances, feed the trailing cables to the excavators. Permanent indictments of 19th century methods are the scars on our landscape of disused workings. These ugly memorials are now a thing of the past. Thousands of tons of coal were extracted from underneath these now so peaceful pastures and fields of corn. The more coal we extract from the earth, the more bricks and cement can be manufactured to build our homes. And it is earth-moving machinery, used efficiently, that is helping to fulfill this urgent demand and maintaining the high output of coal from the company's Opencast coal sites now in operation all over England. But to get at the coal, we must move the earth first. And it is the moving of earth, under all conditions, by up-to-date plant, that has stepped up the production rate and enabled John Laing and Son Limited to maintain a target of 1 million tons a year.